So welcome everyone. We just went through around the table here, did a quick introductory session, and it's good to be back. We took a long break during this year, but we're happy to be back. This is Deep Learning Adventures, a fun and engaging meetup. We talk about data science, machine learning, and specifically deep learning. We covered several interesting topics in the past, anything from TensorFlow certifications, TensorFlow specializations, through Coursera and Deep Learning AI, as well as industry-specific topics like Google Cloud Platform, as well as AWS. We went through a long journey on actually preparing for and getting the AWS machine learning specialty.
Hey, George, are you sharing right now, or?
I'll share my screen right now.
Okay.
Yeah. So you can find us on Meetup, Deep Learning Adventures, and I'll post on chat as well the links. But if you go to our current event, I have several links here, including the Deep Learning YouTube page we have, as well as Slack if you want to join us on Slack. And if you go to our YouTube page, you'll see what we call different playlists. So the latest one was on the Amazon Web Services, two actually specialties or certifications we took. One was like an entry-level certification called Cloud Practitioner. We broke it down into two parts: how to prepare for it, and what was our actual certification exam experience. I think that was useful for many of us. And we did the same for the machine learning specialty, which was way more involved. Some special topics on attention transformers, and then we took this specializations on TensorFlow. If that's interesting to you, we learned a lot there. Data and deployment, Kaggle courses. If you're new to data science or machine learning in general, Kaggle courses are highly recommended on our end. We had a great time covering them all. We had great speakers in the past, and like Moroni here, Lawrence Moroni from AI. Team lead on Google, and other great speakers, as well as special topics like image processing or text or fraud detection, time series prediction, as well as some fun tools like teachable machines, which was super fun. For today's topic, we'll talk about something new. This was introduced a while ago, actually, this simple ML for sheets. And if you go to our meetup, or if you just Google simple ML for sheets, you'll come up to this page here. And I'll try my best to go over it. It's really easy to use. I find it really interesting. And as adventurous we are, we're going to go actually under the hood and see what is happening behind the scenes. So how do you get started? You install this add-on on your Chrome, so it runs on Chrome. You need that browser, and then you go to Google Workplace Marketplace, or if you just Google it, simple ML for sheets, you can install it. There's some screenshots here how to use it. I'll go over them in detail. Then once you install it, you can play around with it. So what can it do right now? It can do 3 different tasks. It can predict missing values, it can spot abnormal values, or it can forecast future values. That's what it can do. So I think there's a resource here on what it can do. Before I dive in, I found these resources interesting, as well as the FAQ. So first of all, your data needs to be in a spreadsheet. That's, I think they have like, let's see, how to format your sheets. Yeah, your data needs to be in a spreadsheet. I make this bigger. Columns. You have columns, and it needs to be of the same type. Basically, the data needs to be in a tabular format and of the same type. The name needs to be unique of the columns, basically the features. I think those are the main ones. Cool. So let me go back to the first task, predict missing values. So prerequisites, you need access to Google Sheets. And actually they have a step-by-step process here, how to install it. And I'll give you the overview of what is going through this documentation page by page. So everything, actually in privacy policy was the best one. Yeah, privacy policy. What was it about? What was it? Okay, there you go. So there was a little bit of questions for me in terms of what happens to your data. Is your data sent to a remote server? Is it being tracked and all that? So this FAQ to me was really, really helpful. I think it'd be useful for us to go through that first. So it's an add-on for Google Sheets. It's developed by the Google Zurich team. It needs access to your Google Drive, and it actually creates a folder in your Google Drive called Implement for Sheets. That's where all the models will be saved during this process. What technology is used is it uses decision forest models, specifically the Yggdrasil decision forest. I was Googling this before the meetup. How do you pronounce this? It's Yggdrasil decision forest. And that's a powerful library that builds decision forest algorithms. If decision forest is brand new to you, there's a great links on this resource. There's actually a Google course on decision trees and why they are pretty good. But I think I came across one link here that gave me the high level idea. There you go, of decision trees. Oops, sorry. So the pros, right? So they're easier to configure, much easier to configure than neural networks. They have fewer parameters and even fewer hyperparameters and pretty good defaults. Like you can use decision trees and decision forest with their default values, and you're going to get good results on your classification regression models. They handle numeric, categorical, and missing features. So that means you need less pre-processing than a neural network. And they give you generally good results out of the box without even fine-tuning them a lot. They give you decent results. They're robust to noisy data, and most importantly, they have interpretable properties. You can take a look at your model and see what is happening, especially for trees. The inference time is much faster than neural networks, so that makes them really good candidates, for prototyping. They can be used for classification, regression, ranking, uplift modeling. I haven't used that. Most importantly, they're interpretable. So this was a good, I'll share this link on chat, but this was a good introductory or reminder or refresher for everybody what happens with the trees, just to make sure I do some level setting. There's some terminology here. Let's say you have a model and you're trying to detect if this is what kind of animal this is. And you might have features like number of legs, number of eyes. So if your model or your decision tree could look something like this. You have the root, and that's the first decision you have to make. You look at a feature, for example, number of legs. If it's less than 3 legs, you know that, and let's assume you only have 3 options, then you know that it's a penguin. That is called a leaf node. There's no other decision to be made. There's no uncertainty here in this leaf node. If now you have more than 3 legs, it could be a spider or a dog, so then you need another feature. And as you can see, this decision-making continues to happen, and your data gets distributed in the tree, and eventually you're going to make a decision. This was a very trivial example. As you can imagine, you can have more interesting use cases, or your data might look something else. I just wanted to give that. There are multiple ways on how to train this decision trees. I think there's a full example here that was useful. It actually uses decision forest from TensorFlow, which uses the Yggdrasil library in the backend. So we'll use this data set as well for our use case in Google Sheets. We have this a subset of this Palmer penguin data set. And the goal is to predict the type of the penguin based on some measured data that they have. So if you want to learn more about that, feel free to go through this course. Any questions, comments, feedback so far? Again, I just want to introduce quickly decision trees before we go too deep. So yeah, under the hood, SimpleML uses this aggressive decision forest. For forecasting, it actually uses 2 ARIMA and 2 ETS models. If you want to learn more, there's links here for what they cover. Can you export the model? Yes, you can export it. Where does it run? It runs on your browser. No data is being shared with remote servers or anything like that. I'm just trying to find the is there any relationship between SimpleML and TensorFlow? Yep, this Yggdrasil decision forest library is the one. Maybe privacy policy. The only data I think that is shared or tracked is which task. So you'll see we have 3 tasks are being used by this add-on. So I think the team just wants to know which task is more popular for them. So is it the predicting missing values? Is it abnormal values? Or is it the, there are some other features as well, like training a model, evaluating a model, understanding a model. Cool. So going back to our first task, you install the plugin. And actually, I'll open here make a copy of this sample data just so you can see it. So this is a copy. Let me zoom in so everybody can see.
I'm actually curious if anyone has tried to test or red team that privacy policy, right? Because that doesn't sound like Google.
No. Let me open the
right? Like, put a bunch of data in a spreadsheet, just do some processing on it, and see what shows up in your ad streams.
Yeah, they say they only track what task do you actually click on, but not anything about your data. Cool. So the data that we'll be working with is this penguin data. It has some information about which island in Antarctica the penguin lives. Let me actually, I was looking at this the other day, bill length penguin. There's an interesting data set that I came across. So these are, this is a good EDA basically on explorator data analysis on this data set. So 3 types of penguins, and bill is their mouth basically, the length of it. So Adelie, Gentoo, and Chinstrap. Blue, I think, is for females, gray is for males, so you see a little bit of a distribution. And this is just for their length, but we have, let's see, under images, I think I came across some more interesting data. Well, in our case, we have more data, right? We have the length, the depth, the flipper length, and their wings, basically, their body mass, their gender, and the year they were spotted. As you can see under species, we have missing values, and we have around 30 missing values. And for the remaining, we have data for the species. And this data set is actually quite small. It's around 340. So a bit less than 10% is actually missing values. So the goal is to look at similar records. And as you can see, my data is not complete, right? I might have missing values even for some of my features, like I do here. So that's interesting observation. So the goal is to see what is common, right? So what makes a Gentoo? Is it the island? Is it the bill length? Is it the width? Is it the body mass? Is it something else? What contributes? What can we basically find patterns in this data that will help us predict the species of this records here? That's the task. And the way to do that, after you install the add-on, if you go under extensions, SimpleML for Sheets, there's a start option. You need to click on that. And once that starts, you'll see a menu on the right here. Zoom in. So you have three options: predict missing values, you can spot abnormal values, or you can forecast future values. There's some other advanced tasks as well, which we're going to take a closer look. You can train your own model based on your own data. You can make predictions on test or evaluation data. You can evaluate the model performance. You want to see how it is performing. What is the, if you're doing a classification task, what's the accuracy and other metrics. You can understand it. Is it interpretable, especially if it's a decision tree model? You can export it and so forth. So for this case, we will use the predict missing values. We want to use the species that's what we're trying to predict. Source columns, we're going to use all of them. In the documentation, it says you can experiment with it, but usually this decision forest models work well with more features. And then advanced options, this is where you choose the algorithm. So we have three options: decision tree, random forest, or graded boosted trees. So I'm not going to change any of the default. I'll use all the columns, and I'll hit predict and show extended logs. So this is running in the backend simple decision forest in your browser with this data and trying to fill these missing values. So let me zoom out a little bit. So what happened is I have now two new columns: predicted species and predicted species confidence. So what this model did is it looked at my missing values, it looked at my features, and based on the trained data, it predicted the species as kin to with 99% confidence. Similar for the other ones, 90, 98, 99, 93, so 93 here, gene strap. So we got what we wanted, as well as a confidence interval in case we want to maybe filter for anything above 95 or 99. Cool. Let me go back to my menu here. So now if I go back, question is, okay, what happened? Like, right? What is my model? What can I do with it? Can I take a closer look? And you can. So the way to do that is, let's say I want to evaluate this model, and click on evaluate. And when you do this, you will get this, what they called model evaluation card. So the total number of predictions, the accuracy, and then this confusion table, right? So you can see it detected. So the way they did this, looking at documentation, is you give access to all your data, but it contains a small subset of the data as a holdout set, as a validation set. So all these results are based on that set. I think if
George, do you know what it did with the missing features?
That's a good question.
Because I thought that's why we would do the missing. When you said missing data, I thought we would do like, those, like the genders missing and some of those values.
So as a refresher for me to look at the trees, first of all, they might not use all the features, right? Some tree might use a subset of the features, and some tree might use also a subset of the rows. So there's a lot of noise introduced here in terms of sampling. So one tree might pick, let's say, this subset, and one tree might pick maybe the middle three features. I didn't see any documentation on how do they deal with missing values. I think that maybe they're missed, or maybe they're not used for that record. I don't think it tries to interpolate it. I mean, that's what you're saying. I don't think it tries to fill them in and then do the prediction. yeah. So this is a similar one. I mean, the same task.
George, what you just described there sounds a lot like, this downsampling the rows, downsampling the columns sounds a lot like random forest. Is there a difference between the decision forest algorithm here, this Yggdrasil, and the traditional random forest approach? You know?
I was
just guessing based on the name that maybe it was doing some sampling of the rows, but not necessarily randomly choosing the columns, like a little bit less random than the random forests.
no, I couldn't tell.
But
I mean,
I haven't looked at this.
yeah, I quickly skimmed through this again. I didn't go in detail. They have a whole documentation side, but from what I got from reading it is that it's a very fast implementation of decision forest. Now, what it's an open source project, right? So we can go to the GitHub and see how they're doing that. How are they doing their sampling? How are they doing their, I mean, it says native support for missing values, but I don't know what that means in the backend. Are they interpolating them? Are they filling them in? Are they just subsampling them? Yeah.
Right.
They also have a paper that they go in detail. So going back, so you select the task, you select the species, predict, you get the columns, and so yeah, what happens in the backend? You look at rows where the species values is actually there, train this model, and then you're trying to predict on the missing ones. And then if you go now to SimpleML for sheets, you should see a new model that was just created. I'll open it. And this is in a protobuf format. It's a zip file, you can download it. It's in protobuf format. You'll see the model being saved in this format. You cannot open it with the editor. You actually need to use the saved format in TensorFlow to actually open it. Okay.
So George,
that was predicting missing values. Yep, go ahead.
Yeah, so George, if you click where it says understanding a model.
Yeah, that's another option. I was saving it for later, but yeah.
Oh, sorry.
It's okay. You can do it now. Let's see, understand. If you selected a tree, you actually will be able to see the tree. How is it structured? Maybe I can do that real quick. But we selected this random forest here, so plotting into interpretability. Let's see how it looks. So these are our features: island, length, depth, flipper length, body mass, gender, year, quality on a subset of our data. This is a subset of the training data that is used to create this confusion table. Accuracy 96%. The data set, this is like, think of it like as a EDA. So they have a nice terminology here. So it will tell you for each feature if it's numerical, if it's categorical, if it has any missing values. You see here you have 1, 1, 1, 8 for gender, sex, right? 4 for island, 4 for species. NAS. Let's look at NAS. So 1, 1, 1, 1, 8. Island and species is there. You can do things like variable importance. So looking at the documentation. So for example, if you look at mean decrease in accuracy, the way these are sorted is if this feature is not there, your average accuracy, model accuracy would decrease by 21 points, 0.21 points, by 21%. So it looks like island is a pretty significant feature in our data. Then the length, then the depth, then the flipper length. They have other metrics as well. I didn't go into details, but they have interesting ways of showing your feature importance by metric. Under predictions, you can see a lot of interesting plots. For example, the length, the bill length with the class, you see there's like a natural cutoff here for this species. So if the length is less than 40, then it's pretty accurate, or it's pretty easy to detect it as the species. This it gets more interesting here for them. You have to look at other features. The depth, the length. This is just a distribution of the data and a density as well as a cumulative distribution function. Yeah. Plot is not available unless you select the decision tree, right? Otherwise, you have this is a forest. It's not easy to visualize. So let me actually change this to, so I'll undo, right? I'll delete my data. And the only thing I will change is predict missing values. I'll make a decision tree. And let's predict. So we can see that understand a model feature a little bit better. Okay, cool. So now go back. Okay, so I have a timestamp. There should be 7:39. Understand. The confidence is high, but it doesn't mean it's accurate. Okay, so similar layout. Data set, importance, looks like the length is very important here. It's only one tree, right? Predictions and model. There you go. So these are our three labels, and this is our tree. The first feature we're looking at is bill length. If it's more than 43, then we have more decisions to make. If it's less than 43 millimeters, then we evaluate it as a deli. If it's more than 43, then we have to look at the island. If it's in this set, then we predict Ken 2. And if not, I think we need to look at the yeah, so positive, if the island is dream or tortoise, we predict Ken 2. If not, we predict chinstrap. And then for those two islands now, yeah, I think that's it, right? Oh, when is the last case? If greater than 43, and if my island is not one of them, then I need to look at the mass, right? And look at the mass, then I can make a decision if I do this properly.
Yeah, it looks like it's coming back to bill length for a second branch on the
Oh,
same.
it's coming back. Oh, okay. Yeah,
Yeah.
I just noticed a different.
4 levels there.
Okay. Yeah, interesting tree, right? So imagine having multiple of these, each of them making their own path.
So those vectors that are shown there, are probabilities based on observation in the tests in the training set. No, validation.
Yeah.
That's probably val right there. That's why it says val.
Yeah. So a subset of your training data is used for validating. So yeah, I think that's what you're seeing here.
Is that using the out of sample? Because this was one tree, right? So there's just some of the data was randomly selected to be in the training set.
Yeah, this should be the out of sample. Yep. And again, if this is new terminology to you, let me remind us. I found a nice visualization here that helped me. So when you're creating this collection, right? So you can have these features, let's say 1, 2, 3, 4, 5, 6. And let's say I have one record that has the content from each feature. One tree can use feature 1, feature 2, can use feature 4 in 2 records, and then feature 5, feature 6. The second tree could use feature 1 in 3 of its records.
This is
This
the samples, not the features, right? Like it works the same way, but this is showing how the trees get bootstrapped to be the same data set size.
exactly. Yeah.
Even though they don't necessarily use all the trees, so you do get some out of sample trees, like the zeros that we see.
Yeah. And then when you evaluate them, because you mentioned that, the evaluation is done out of bag. So if decision 1 used feature 1, 2, 4, 5, and 6, then it will be evaluated on records that, or on records that didn't use this training example 3. So actually, these are training examples. Sorry, these are not features. These are training examples. Okay.
And then the features, are they, the trees may be able to select all the features? The features are not randomized, just the sampling?
During training, you mean? In this case, let's say it's using all of them: length, island, length, mass. So it's not using flipper length, and it's not using gender, it's not using year. Right? If I'm looking at this.
Yeah, we don't know if that's because of the algorithm or because of the data.
From what I remember, you subsample both the features and the record. You don't want to give all the features to one tree, otherwise you might overfit.
Right.
Awesome. So the spreadsheet, yeah, of course, the spreadsheet has multiple tabs. This is just one of them. And I went through the documentation here. The next one is spotting abnormal values. So I'll actually follow the documentation because it has screenshots. So we'll do a similar approach. It's a different data set here. And in this case, we're trying to look for abnormal values in this abelons, the type of marine snail. So we can predict their age based on the number of rings they have on their back. Actually, let me look at this data set here. So we have the shell, the diameter of the shell, the height, the weight, and so forth. These are features, type, and the rings. And we have the data for all these features. We're just trying to predict it to see if any content in this ring feature is abnormal based on similar values that we see in the training data. So to do that, we again, we start our plugin, we select the task of normal values, we select the rings. So let me do it real quick. So spot abnormal values. I want to focus on the rings as my abnormal values column, and I'll pick the boosty trees again, spot, let it run. It only takes a few seconds each time.
Hey, George, question for you while we're waiting.
Yeah.
So for each column here, I noticed that it breaks them up in terms of they're either numerical or they're either categorical.
Mhm.
Do you have any control over that? Because sometimes you have things like zip code looks like it's numerical, but it's not, it's categorical. And things like you think about medals in the Olympics, those are clearly numerical, they're ordinal, actually, they're not categorical. Do you have to manually change that in your spreadsheet, or does it let you control that?
That's a good question. Actually, I came across it here in their FAQs. So the column autocomplete is similar to what your question is asking, right? What you're asking. It's composed of zeros and ones. When predicting missing values, the results are numbers. So in this case, you have binary values, but this one is giving you in between values. So he's saying the FAQ is saying that the type of the model is detected automatically from the label. So
yeah, I'm thinking more of the features, but it looks like maybe you have to do the same thing for the features.
Yeah, so in this case, if their example is if you have a binary class, maybe you have two features, a 0 and a 1. You break it into specifically two columns. That way the model will
Again, that's for the labels, but like if you had zip code, would you
I see. So I think in Sheets you can, let me see.
maybe declare it to be strings instead of numbers or something, and
Right.
then it would say, hey, these are categorical.
So
so maybe you set the type there. Okay.
So I know formatting you can do, but it's not just formatting. I actually want to change the type to whatever you want.
Okay, so then the thought is if you change the type of in the column, then the model will pick that up and adhere to your type.
Yep.
Okay, thanks.
Yeah, there is a way. I mean, I know you can do this in maybe I can find it later, but there's a way to specify the type of the column. Yeah.
And Excel, it's in a format and menu.
I have a hard time hearing you, Paul. Say that again.
Oh, I said in Excel, you go into the format,
right.
Something you change the type.
Yeah, that's right. No, you can go under format. You can say, oh, I want this to be a number or text, but I don't know if it's stored in the backend as that, or is it just displaying it?
The type of number.
Yeah. Okay, so this abnormality score, it gives you two new columns. One is what they call an abnormality output is between 0 and 1. 0 means it's pretty abnormal. There's nothing different to it based on the features it's seen. If it's close to 1, it means it's really different than what it's used to seeing. It also gives you what is a most likely outcome for this column ring. So you see, it's interesting because this has a score of 0.04, and the most likely rings is 8 versus 15, which is in the label. This is 7, this is 8, 9, 11, 10, 9, so kind of close, as you can see. Let's pick some more abnormal ones. So this 18, the model picked it up as 10. And you can sort this obviously by, let me sort them by Z to A. So yeah, this is the most abnormal one. For some reason, the model detected that based on this feature, this ring is 29. It should have, or it's most probably is 12. And on their documentation here, they have a good explanation. So you sort them, and it says the first one has 29 rings, which is a lot, but the model thinks that this should only have 12 or 13. In other words, this is a very old snail, but it looks much younger. I find that interesting, based on the diameter, the height, the weight. It has multiple rings, but it looks younger. Cool. So behind the hood, there are 10 different models that are trained here using tenfold cross-validation. and then each value is compared to the prediction of each model. If they do not match, then it's considered abnormal. And they have a whole documentation here, which we're not going to get into, of how is that computed. This I find interesting. In many situations, it's normal to have abnormal values. Playing with words here. And it is abnormal for all the rows to have the same, to behave the same. Just because you have an high abnormal score does not necessarily mean that there are errors or something is misreported.
So I think this is really useful though, because it lets you look for them. I mean, look at them and see what, you know.
Yeah.
You should examine them and determine, is this normal or is this something wrong in our data? You know,
Mm-hmm.
It needs to be cleaned. Yeah.
Cool. Okay. Then the next one is forecasting. So let me look at the data set for us. It's a time series data, so the prerequisites here are that you need to have, let me zoom in a little bit, a date field. And you can have univariate series, meaning you only have one feature here to predict. I think this is like number of items of a product that was selling. Let me go back to my documentation. Doesn't say anything about the data set. Okay.
Saw something about monthly passengers in there while you were scrolling through. So maybe. Yeah.
Okay.
Air travel, there it is.
From your data analyst and air travel company in the 60s, and you have records of number of monthly passengers from 49 to 60. Your objective is to predict traffic from 61 to 63. Thank you. I read it. I forgot about it. So yeah, your goal is to predict these missing values from 61 to 63. So to do that, and we don't have a lot of data, right? You can see we have what, 174, and we have only 145, 144 of them. So not a lot of data. So we'd go to our ML sheet here, forecast. We want to use past data to predict future values. What column are we trying to predict? The value. Since we only have two features, you won't see much. Seasonality mode. You can actually do holiday as well, which I find very interesting. You have global, no holiday, US, Japan, Asia, Europe, Middle East, and Africa. So it takes into consideration holidays, spikes, remove spikes, normalize trends, if it contains cycles or not, and some growth component and some trend component.
The options under trend.
Magic, Auto EDS, Auto REMA. So is this, I think, a combination of both is the first one. The trend is predicted using an ensemble of REMA and ETS. Okay.
George, what are the,
Go ahead.
no, I just was wondering what the options were under the seasonality mode.
Okay. Seasonality mode, I have auto or on off.
It's just,
Most human activities are fundamentally cyclical, for instance, day, week, all that. So if you know fundamentally that your data is not seasonal, maybe you turn it off, I guess. I guess this is where some tuning might be helpful.
yeah, I just was wondering if there was like some form of like FFT under the hood that was trying to calculate the cycles.
Yeah. So this comes with a new value. So the existing values are here, the new values are here. But most importantly, I think this chart helps helps us a lot. So in blue, we have our existing values. And it's an actual interactive diagram. You can do like last 6 months, last year, last 3 months, max. In blue is our training data, and then in red is our predicted values for those couple of years. I find it interesting because this is very seasonal data, right? You see the lows are in end of the year, November, December, and the highs are in the summer, like June, July, August. So that's what the model is picked here. So end of year, summer, end of year low, summer high, which kind of makes sense based on what we see. Travel. Yeah.
I find it interesting just looking at this, how rapidly air traffic grew after World War II, right? Like this is a 3-fold increase in a decade, isn't it?
Yeah. Yeah, let's see what there was some comments here. Those columns, predicted value. So it shows the same cyclical pattern as original values. Also see that we forecast that the traffic will continue to grow. Okay, this was one feature. What if we have multiple features? What if we have something like this? What if we have multiple stores, one in London, one in New York, and we want to track how many toys and books we sell? What is the sale for each of this product, right? By end of week. Looks like weekly data. So we have 4 series, and there's some correlation here, right? So we expect maybe toys on different locations to sell similarly. I don't know, departments or locations. So we want to predict we have data till 2012, and we want to predict, I think, less than a year worth of data from a couple years of data. So yeah, multivariate forecasting. This is called, you have multiple features as input. You also have multiple features as multiple labels as output. Weekly sales of 2 departments. So store name and store characteristics. Okay, so we'll do the same. Forecast future values. I want to consider all of them as actually I want to forecast all of them, 1, 2, 3, and 4. I want to use the location as a department as my categories. I'm not going to change anything here. And I'll wait for it to run, and it will create 4 new outcomes. And this is what we're going to look at. Let me zoom in over here. So let me close it for now. So you see, this is the C4 is the green one, and the training data ends here, and this is the predicted values from here. Let me zoom out a little bit. Can I see the time range, please? Yes, there you go. So green is the orange one, yep, the 4, and you see some spikes rather, right, in the training data. So for example, here you see spikes in all of them. When was this? April 2010, October 2010, maybe holidays.
We're predicting that calm trough, right?
Yeah, but I'm trying to see where these peaks are. Are they on holidays? April, February, November. What is this? This looks like December, Christmas, February, April. So something is happening February, April, November, maybe Black Friday, and December, Christmas. And our data, does it have April and February? May? No. June, July. So we don't have any. I'm curious though, if I keep going, will it predict those peaks? Should we try? I don't see anything for, yeah, October. Curious.
You can see the bottom two, I don't know what categories those are. They're starting to slope up.
They're
like-
starting to pick up.
Yeah.
Okay, let me delete this actually. So these are the predicted values, right? As you can see. Let me keep going maybe. Let's see if I can push this model. Let me delete this visualization. Okay. Maybe here. Okay. Go to my extensions. I think I closed it. Okay. So I should have, yep, November and December here. Good. So forecast future values, all of them. Yes. Woohoo. I close it again. And let me zoom in. A bit more. Okay. So let's see what it picked. Maybe can I make this bigger? Make this bigger.
Did pretty well, actually. Yeah.
Yeah.
So when it's doing when the model is training and running there, that's all in the browser, right?
All in the browser. Yeah. All in the browser.
Okay.
December. You picked December. And what about November? Something in November. Yeah. What is this blue? November. Pick something for only for these two. Is it because that doesn't happen for the orange and the green series? Interesting. Yeah, maybe they don't have this November peak, but December is for all of them. Yeah.
So I can imagine scaling this data set up, right? And instead of having 2 cities and 2 different types of products,
Yeah.
what if you had 20 cities and 20 different types of products? You know, do you think the model is doing some kind of do you think it's looking at the hierarchical nature of the columns itself? You know, in theory, you'd like to be able to learn that books have a different buying pattern than toys, or that New York shoppers have a different buying pattern than London shoppers or Buenos Aires shoppers or anywhere else in the world. So you think it could improve its predictions if it's able to somehow leverage that?
Yeah.
Or is it just doing some kind of matrix column unaware approach?
No, I think it's trying to take advantage of that hierarchy. Yeah. So it's saying that
okay.
by default, single series are forecasted independently. But if you want to forecast them together, provide one or more categorical values for each of the series. So if they have similar categorical values, they'll be forecasted together using this hierarchical reconciliation algorithm. I'm not an expert in this. There's a book here that they recommend on forecasting principles and practice. But looking at it, it's basically trying to do what you're mentioning, Robert, of trying to understand what is the hierarchy here and how can I take advantage of that. Yeah, so in this example, they have like a sales category, sales data set, but they also have a type. So lemonade and orange juice are both sodas and drinks. So they expect them to sell more or less the same, but wine is not a soda. It is a drink though. So yeah, cleaning, holiday, seasonality, trend structure using this hierarchical reconciliation algorithm. Not familiar with it, honestly. So
Yeah, I'm curious. Thanks.
but interesting in the FAQs. Let me go back to my FAQs. Forecast. Can I export it? Currently, no. I don't know why. Is that a secret sauce or I don't know? because the rest saved. Finally saved. We export. There was a. Okay, I need to find it. Saved. So that was a forecast. Uniseries or multiple. Oops, sorry. Multiple series. Then the rest of the documentation goes into what if you. So what if my data looks different, right? What if my data, as long as it abides this columns here, restriction, right? So it needs to be organized in columns. It needs to be tabular, basically. Same data type, column names needs to be unique. And as long as your task falls in any of them, you can utilize it. There was another option that I didn't explore. Hold on. Let me delete this. Under extensions, simple ML for sheet start. Especially the first one, under predict missing values. I think you can do it for all of them, but under advanced task, you can do export model. And let's see, I have my predict missing values that I did earlier. I can hit export.
Sure. While you're running, I think Jason found the answer to the question. I was going to say there was a question in the chat about how to actually do that plot. Was it just a right click and some drop down to make the visualization?
Is this about the forecast?
Yeah.
The forecast will generate it at the end of it. It's automatically generated for you. It's actually part of the Yggdrasil library. So if you go through it, that's what I was doing. I was going through the library and let me see. The plots that I saw here were very similar to, maybe training API. I don't know. I saw it somewhere here where the plots are very similar to what I'm seeing in Google Spreadsheet. So in the backend, it uses, here. This is exactly similar to the plots that we saw before. So it's actually a feature of the Yggdrasil forest, Yggdrasil library. Oops, this is the model. And then I was just exporting the predict species model. So all you can do is you can copy paste this code into Colab. It won't open a Colab for you. But what that will do is it will install the TensorFlow Decision Forest library. It will import Google Drive. It will mount your Google Drive. And it will copy your data from simple ML for sheets to a new directory. It will import TensorFlow and Decision Forest. And it will actually load this entire model. So if you remember, I had this as a model. You'll actually try to import all those files as one model description. And it will load it to a Keras model. And then now this is a trained model. All you need is some labels, some features, and you can predict and get your labels out of it. So actually I did this. Let me see, where's my, actually I can copy paste this real quick just to see how easy it is. So let me do a new notebook. I made a bunch of code. Let me do it step by step. This needs to run first. then this, then this, and then okay. So I broke it into different parts so I can understand a little bit better what's happening. I think I have do I have multiple copies of this? I have multiple copies of this. I'm not sure which one I'll actually import at this point. Maybe the latest one. Any other comments? Sorry, I see a lot of comments on the chat.
So one thing I think is pretty cool. The only thing that gets me a little bit is because it's for Sheets. Are a lot of companies using Google Sheets? Because I know, obviously I'm in healthcare. My security would lose it if I did anything in Sheets, even if it didn't have, patient data. How frequent is Google Sheets allowed with other companies?
So when you do this, you actually would get the enterprise Google account, similar to what you get under Microsoft. So they would have it's a very different product. Yeah, it's not the one that I'm using right now. It's an enterprise level, and there you have all the security, all the permissions, all the data governance that you need as an organization. Yeah.
Okay, so you get your BAA and all that good stuff, and security would be happy, and we can all go about ourselves. Okay.
Exactly. Yeah. Your data doesn't leave your own infrastructure. I mean, it's in the cloud, but even Google themselves can have access to your data. So
and Excel's like that too now, right? With the 365, it's all in the cloud.
So yeah, you see, I mounted that my Google Drive. I can access anything pretty much now. I import the libraries. This is a protobuf format, and I'm loading the model in the Keras model. We had a command, right? What was it? Model dot. Especially for neural networks. Okay, save model. Then these are my examples. And then you'd get logits, right? You get probabilities for each of the three classes. So remember we had, close this, 3 different species. So the first one is probably the second in row. The one is the next record is the first one, and the other one is also the first one. So we have 3 data, right? This is the year for the first, this is the island for the first, this is the flipper length for the first. It's as a matrix. And all we're doing is we're fitting these features and we're trying to get the species. So you can do this on maybe in a small subset of data, right? Where you have, to your point, if you don't feel comfortable with it, maybe you train on a small subset of data. You export the model, and then this is a Colab. You don't have to run this on Colab. You can run this on your own Jupyter instance, which is local to your computer, or you can run this on your own remote device, right? I see that does. You can obviously need to downgrade this, downscale this a little bit in terms of size, right? Quantize it and all that, and you can run this on a small portable device.
Have they given any indication of what tasks people are using this for the most? Are they holding that close to their chest, as they say?
Yeah, no, I mean they have a user group that I I'm looking at, people can report issues or add features or ask questions or recommend to contribute. I haven't seen anything around new. I just joined this, so I don't know. Yeah, is there anyone about new releases?
I guess I would guess people are using it for forecasting the most, but I you know, from a business standpoint, but I could be wrong.
Right. Yeah, date formatting, predicting values. Yeah, this is like a user group, Google user group. Think of it as like.
Yeah, David, a lot of people use tools like this for preliminary research. On the Python side, I don't know if you're familiar with Teapot. It's just spelled TPOT. But they're auto ML solutions. And so like if you had a bunch of data and you were just trying to see what you had, like if you run Teapot, it'll run decision trees, random forest, and gradient boosted trees, and then give you a report back saying, you know, here's the most significant things we found in your data.
Yeah, I definitely I know lots of people use auto ML to get started, right? And then they choose whatever they're most robust, and then they'll hand code it or whatever. But I was thinking this would be used by a lot of business people who don't know how to go beyond this,
right?
But they could use it for forecasting and a lot of the tool, you know, a lot of that stuff. But I don't know. I'm just taking a guess.
Yeah, and back to the security side of it. So all the operations are executed on a computer in your web browser, and your data is not exported to any third-party server. And the only other what data is actually shared is does not export or share your data with third parties. All operations are executed in a web browser. All your data is kept only in your browser and your sheets. Models are only saved in your Google Drive. So if you have an enterprise level Google Drive, you're good to go. Then this uses Google Analytics, which may use cookies to collect information on what do you click without personally identifying any visitor. So they might include which task you're using, predicting, spotting, training, evaluating, understanding. And they're used internally to understand which tasks are popular and where to focus their development efforts. They don't include any information derived from your data. That's what they say. Yeah, to your point, yeah, this is like, maybe this is for like business analysts or non-technical people who are pretty good with spreadsheets, and they just want to take a stab at one of these tasks without having a data scientist on their side. Cool. I hope you found this interesting. Again, the documentation is there. If you really want to dig into this, maybe this, I think that, you know, needs a separate session. Like I barely scratched the surface on this library. If anybody's interested, maybe we can do another follow-up on this, but there's a GitHub page. This resource from Google was very interesting. And I think that's all we had for this. Let's see what else we have here. Last other couple of tabs I didn't go over. So that was the first, that was the second case, third case. There is an option to, so this is my training data. Let's say now you can actually go here. You can use this train a model option, give it a name. So let's say I have even more data, or I don't want to fill any missing values, right? I just want to see here I have missing gender. I want to train this, and then maybe later on I want to deploy it somewhere, right? It doesn't have to be for filling missing values. Filling missing values was just one use case. In general, you can train a model on this data to predict something. So in this case, my ELA model, I want to predict the species based on all my columns. And here is where you're asking if I can change this. I don't seem to be able to change it here, but I'm hoping I can change it on the format here and train it. And then let's say later on, I get my evaluation data. So this model I can take, I can deploy it somewhere, or I can evaluate it, right? Evaluate a model, my DLA model on this spreadsheet. And this, I think, will give you even more statistics on model understanding. There you go, model evaluation. So accuracy pretty good, no errors. 41, confusion table looks great. ROC perfect, 1 line. Precision recall, 1 line. Threshold accuracy. So yeah, on this specific data set, maybe it overfitted. I don't know. It looks too good to be true. It looks like you got all of them right. And then is there an understand the understand the model, ideally. So yeah, this is the summary. Quality. Okay, I did 1 error here and 1 here. The data set, the importance. So length is most important here, then island. That's interesting. The different visualizations, model we cannot plot. But this was interesting. How to read the prediction analysis. They have their own dedicated page on also they're evaluating matrices. So accuracy, confusion matrix, log loss, receiver operating characteristic, PR, regression, is regression, conditional plots. I haven't used all of them, so I'm curious. They are under here, under the Yggdrasil documentation now. Cool, that's all I had. Anything else before we wrap up and talk about next adventures? This was a lot of content, so I appreciate everybody's patience.
I thought it was interesting, especially kind of seeing where some of this type of stuff is going. It's really putting it in the hands of everybody.
And speaking of, it reminded me of something. Speaking of spreadsheets, I think Microsoft just released this feature literally yesterday. I don't know if it was there before. I haven't seen it, but you can now run Python in Excel if you want to do that. I don't know why you want to do that, but they collaborated with Anaconda. Yeah, I saw it yesterday on the news. They collaborated with Anaconda, and now you can go crazy. You can even do SNS, you know, Seaborn libraries here within Excel. So you don't have to leave Excel. Oh, there you go. SNS. I remember this. Yeah. Doesn't this cool? Doesn't this look cool? I don't know. Thoughts, comments, feedback? I don't know.
I mean, I don't know. I'm not a huge fan of spreadsheets in general, to be honest. So any chance I can get away from them. So this is like trying to pull people back in it. But there's some people who never want to leave them. Exactly. Maybe this is a way for them to transition to Python, sort of, right? It's a transition.
Yep. I know people who just live there. So yeah, to them, like, yes, this is great. My macros can do this. Okay, give me your Python code. I don't know if you can run TensorFlow on it. Or pandas. I'm sure pandas you can, but yeah, it's a new feature. It just came yesterday.
I mean, there's definitely a use case here for teams that have some people who don't want to leave Excel at all, but then you want to do some programming or business or processes that are just too clunky to do with Visual Basic, and you know, there's a market for this, I imagine.
Yeah. Cool. So what is coming up?
All right, let's point out one more one more benefit for those of you who've dealt with many trials and tribulations of the Python libraries, and whether you're using pip or conda or whatever and all that. Hey, Microsoft's taking care of it for you in Excel, so you're good to go.
Like to see that. Cool, friends. Then what is coming up? I have we have several sessions coming up. One of them is this 2 podcasts from these AI companies, Google and OpenAI. I find it really interesting going over them. I have the links here. Feel free to listen to them, and I'd love to get together next time and chat a little bit about generative AI, and what is the race, AI race there. And I learned a lot from both of them, so feel free to go over them. We'll convene, we'll get together as a community and talk a little bit about this. And then this will be our entry point to generative AI. We have way more content coming there, and especially from deep learning AI. So after this call, I'll post the upcoming sessions. We will follow these short courses on deep learning AI. I'm not familiar if you've seen them before, but they're very short. Think of it as total video hour is 1 hour. You probably need several more hours to understand the concept, but anything around generative AI, specifically ChatGPT. So I'm going through the first course myself. It's pretty amazing what you can do. Think of it as whatever you can do from ChatGPT from user interface perspective. Now you're going from the back end. You'll connect to your ChatGPT account using your API key, and you'll use the ChatGPT APIs now as a developer. And you can summarize text. You can generate in a specific tone. Any sky's the limit here. Like all the things that were not possible are there now. So hallucinations are there. How do you anchor your model and all that? So there's a whole new adventure coming up around generative AI. So I looked at all of them, and actually they're sorted chronologically in how they were developed. So we'll start with this one first, prompt engineering for developers, then building more systems. This is an open source platform called LangChain. How do you use that too? And how do you bring your data, right? The big question is, how can I bring my data in a nice, safe, and secure way? It doesn't leave my on-prem infrastructure. How can I do that? So there are ways to do that with open source libraries and your own private infrastructure. Fine-tuning them, semantic search, applications using Gradio, which is similar to Streamlit, and then evaluating, debugging them. And there's one on diffusion models, which is great. And then
noting that these courses are, I don't know if all of them are brand new, but the vast majority are. I mean, I think I looked at this page a month ago and it had half as many courses.
Yeah, they're coming. Yeah. They have.
Do these all link? Do these all link to Coursera?
No, they actually.
Now, once I clicked on one of them, they run on that platform.
They're on that platform, yeah. So when you enroll, when you log in, the platform looks really, really nice. They took lessons learned from Coursera, and when you go here, you'll see your content, but let's say I'm going to click on the next one, and it will split your screen into the content, and then it will actually spin off Jupyter Notebook here, which you can use for your own development. So yeah, it's really neat. It's within their library here. You can export it if you want, but it's a really nice platform. Cool. So yeah, this is coming. I'll post the recording. I'll post the session, upcoming sessions. I don't know how it's coming. People are excited. How frequently we should meet, right? Because they're not that long, but they're not that short either, because it's brand new information. So maybe we do the first one, we learn the terminology, we get used to the new adventure, and then we figure out a good meeting frequency. I don't want to just schedule them now, and then later we realize, oh, we need to shift things around.
I think it's evident that they're gonna push these things out faster than we can go through them.
Yeah. The other ones I saw, they posted 2 new ones. I found this one very interesting. I haven't taken it, but I saw an interview by the instructor. So this is using AI for like humanitarian purposes, air quality, climate change, satellite imagery, wind power forecasting. So really good, really good.
I think this one may be accessible to beginners as well.
Let's see, what does it say? Introductory, yeah. And then there was one that they developed with Amazon Web Services. This one is also new. This is for more like intermediate to advanced. So this is, maybe we can take in the end after we do our short courses, we can take this one. Usually I have like, what will I learn? Okay, what? Yeah. So we have a lot of content basically. We'll start with the short courses and then we'll tackle the specializations. Cool. So yeah, I'll post the recordings on our YouTube page here. I started a new playlist, but if you want to join us on Slack as well. Post it here, and then everything will be posted here on YouTube. And feel free to listen to this podcast. I found 2 additional podcasts after this that maybe we can do on maybe on a monthly basis. It's a new platform for us. I'm curious how we can learn from it. Cool. I'll stop the recording here and leave the floor open if people want to hang out.